Hello everyone, welcome back to the channel. Before we start our class, I want to show you a video about hot water and cold water. Try to keep in your mind, did you have experienced the situation in this video? Let's watch it together.
By yourself. Okay.
So how? Did you have experienced it before? When you suddenly touch the hot water, then you get shocked. And then your hand get hurts. And sometimes the injured parts become red. Same goes to the baby. And then you quickly cool it down by using the cool water. According to this video, why we get shocked when we touch the hot water and why we are using the cold water to recover it. Actually, this situation is related to thermal equilibrium. So today we will learn the topic of heat with the subtopic of thermal equilibrium. There are one learning standard for this subtopic. So I hope at the end of this class you will be able to explain with examples thermal equilibrium in daily life. Let we start with the important terms in this subtopic. There are three important terms that I want to highlight here. First, temperature. Temperature means the degree of hotness of an object. And the unit that we can use for temperature are Celsius and Kelvin. As you can see in the picture here, there are two thermometers. Thermometers at the right side was measure a hot object. Meanwhile, the thermometer at the left side was measure the cool object. The higher the reading of thermometer means the higher temperature of the object. Therefore, we can say a hot object is at a higher temperature than a cool object. The second thing is heat. Heat is a form of energy, and the unit for heat is joule. Here we must know that when object is heated, it will absorb heat energy. Meanwhile, when object is cool, it will release heat energy. And the third term here is thermal contact. Two objects are in thermal contact when heat energy can be transferred between them. Now, let me show you what is thermal equilibrium. There are two objects with different temperature here. We can say hot object is in thermal contact with cool object. So, heat energy can be transferred between both of them. Heat transfer from hot to cool, which is 100 joule, is higher than heat transfer from cool to hot, which is just only 20 joule. This is because hot object has higher temperature than cool object. And it also means there is a net transfer of heat between both of them. If we can calculate 100 joule minus 20 joule, so the net heat transfer is 80 joule. During this process, the temperature of hot object will drop. Meanwhile, the temperature of cool object will rises. After a few moments, both objects have same temperature. That's why there are 75 joule of heat energy from both sides. Since heat energy transfer from both sides are same, therefore the net heat transfer is 0. So here we consider object has reached thermal equilibrium. So now I highlight again the conditions of thermal equilibrium. First, the object should have same temperature. Second, the object should have same heat energy transfer, meaning here the net heat transfer is 0. Now let's move on to the application of thermal equilibrium. For heating process, we can see the application of thermal equilibrium in oven. So how it will happen? Okay, imagine you put a chicken in oven. Hot air in oven is in thermal contact with the chicken. Then, the temperature of chicken will continuously increase until it has the same temperature with the hot air. At this moment, thermal equilibrium is reached. Therefore, the chicken is baked. Next, for cooling process, we can see the application of thermal equilibrium in refrigerator. So how it will happen? Try imagine the food in the refrigerator. Cool air in refrigerator is in thermal contact with the food. Then the temperature of food will continuously drop until it has the same temperature with the cool air. At this moment, thermal equilibrium is reached. Therefore, the food stays fresh longer. Now, let's try your understanding. Ready? Question 1. Diagram shows 200 gram water with initial temperature 80 degrees Celsius and 50 gram water with initial temperature 30 degrees Celsius. What will happen to the final temperature when the water mixed together? Is it A. Temperature achieved less than 30 degrees Celsius? Or B. Temperature achieved 80 degrees Celsius? Or C. Temperature achieved more than 80 degrees Celsius? Or D. Temperature achieved thermal equilibrium? So, the answer is D. The final temperature achieves thermal equilibrium when the water mixed together. Question 2. Diagram shows hot coffee at 80 degrees Celsius is being poured into a cup at room temperature. When thermal equilibrium is reached, what will happen to the temperature of coffee and cup? Is it A. Both coffee and cup has increased in temperature? B. Both coffee and cup reach same temperature? C. Temperature of coffee is unchanged while temperature of cup increase? Or D. Temperature of coffee is dropped while temperature of cup unchanged? So the answer here is B. Both coffee and cup reach same temperature. This is because same temperature is one of the conditions of thermal equilibrium. So far, that's all for today. So I would like to thank all of you for watching this video. I hope we will see you again. Bye.